All right, welcome to another exciting lesson here. This is 4.2, multiplying complex binomials. These are binomials that involve both variables and also our I term. Okay? To do this lesson, we're going to start by multiplying complex polynomials, and it's going to be very similar to what we've done before. We write the first polynomial along the top, the second polynomial along the side of our multiplication Punnett square. We multiply to fill in each box. We remember to multiply the coefficients and then add the exponents. A couple other things that are new here. We have to remember that I squared has a value, and that's equal to -1. We remember I is equal to the square root of -1. If you square that quantity, you're going to have I squared is equal to -1. So anytime we see an I squared, we're going to replace it with -1. We're going to write the polynomial in standard form by adding the diagonal terms together. A plus bi is going to be the form that we're going to answer it in. Okay? All right, let's move on to our next slide. So our first problem here is 2 plus I times 3 minus I. And again, just like we've done in the previous problems, we create a 2 by 2 multiplication array, Punnett square, whatever you want to call it. Take the first one, put it up top. Doesn't really matter if you put it up top or on the side. Take the second one, put it along the side if you put the first one on the top. Make sure that your second term in the binomial has the operator attached to it. That tells us whether it's positive or negative. When I multiply together, I get 3 times 2. Here I get 3 times I. In this square right here, I'm going to get -I times 2, so I get -2 times I. And over here, I'm going to get -I times I. If I go through the math here, my Punnett square, when I multiply 2 and 3, or 3 and 2 together, I get 6. 3 times I gives me 3I. -2 times I gives me -2I. And down here, I'm going to get -I squared. Okay. I also recognize from my diagonals that they're like terms. So I'm going to go add things together then. And what I'm going to get is 6 plus I minus I squared. And where do I get this I from? I get it from the fact that I get 3I minus 2I is equal to I. Okay, that's where I get it. So now I got 6 plus I minus I squared. But I remember I squared is equal to -1. And actually, I'm going to do that in different colors so it's very clear. I remember I squared is equal to -1, so therefore I'm going to get 6 plus I minus, in parentheses, -1. When I work through that, I get 6 plus I plus 1. If I subtract the -1, it becomes a +1. These now are like terms, and I can add these together, and my answer, therefore, is 7 plus I. And that is 2 plus I times 3 minus I multiplied together. Ends up 7 plus I. In this next equation, again, 12 plus I times 3 minus 2I. Similar problem. Now we have a coefficient on the I. It just means I have 2 I's instead of 1 I. So go from a cyclops to a normal human being. That was funny in my mind. All right, so I draw my Punnett square. 12 plus I, 3 minus 2I, and I begin my multiplication process. 3 times 12 is 36. 3 times I is 3I. -2 times 12 is -24. Bring over the I. And here we get -2 times 1 is -2. I times I is I squared. Again, we notice that we have like terms on the diagonals. So I'm going to get 36 minus 24I plus 3I minus 2i squared. Okay? Again, these are like terms, so these are going to become 36 minus 21i minus 2i squared. But we must remember, I squared is equal to negative 1. So therefore, we're going to plug that in place of I squared. And what I get is 36 minus 21i minus 2 multiplied by negative 1. Continuing on, I get 36, still minus 21i, now plus 2. Negative 1 times negative 2 gives me plus 2. I realize I have like terms between 36 and 2. I combine them and I get my final answer of 38 minus 21i. On our fifth example here, now we have two coefficients on I. Not really changing anything, still the same type of problem. Again, start with a 2 by 2 Punnett square. 2 plus 4i, 5 minus 8i. 5 times 2 is 10. 5 times 4 is 20. Bring down your I. Negative 8 times 2 is negative 16. Bring down your I. Negative 8 times 4 is negative 32. We're multiplying the coefficients. The exponents on I are 1 each, so it's going to be I squared. Again, we notice like terms. This is going to give us 10 plus 20i minus 16i minus 32 I squared. Like terms here, we're going to combine those, and we're also going to remember I squared is equal to negative 1. So negative 1 is going to go in the place of I squared. And we're going to condense a few steps here. So I have 10 plus 4i minus 32 times negative 1. When I go through this, I end up with 10 plus 4i plus 32. I recognize these as like terms, the 10 and the 32. I combine them together and I get 42 plus 4i is my answer. Really, all the rest of the problems we're going to look at today are very similar. Suddenly things change on our fourth example. What we see here is I get x now, our variable. But really things don't change. The same concepts are still going to occur. We're going to multiply coefficients. We're going to add exponents. We're going to do this like we've been doing. Nothing has changed. So, again, start with our multiplication array, multiplication table, Punnett square, whatever you want to call it. X plus I, 2x minus I. 2 times 1 is 2. The exponents on x are 1 each, so it's 2x squared. Add the exponents, multiply the coefficients. 2 times 1 is 2, x, I. In this case, I have a negative 1 as my coefficient. Negative 1 times negative 1 is negative 1, x, I. Or is it ix? I think it's going to be the other way around, actually. And then I take my negative 1 times 1 to give me a negative 1. I times I gives me I squared. So what I end up getting with this problem here, oh, and by the way, identify again, I have like terms on the diagonals. It's not always going to happen like that, but more often than not it will. So we end up with 2x squared. We're going to call it ix plus 2ix minus 1ix. I just switched around the order there. Ix is the same as xi, but it's probably the better way to write it. And then finally I have minus 1 times I squared. Again, I remember that I squared is equal to negative 1. So I'm going to substitute that in for I squared. And what I get is 2x squared plus ix minus 1 times negative 1. And so what I'm going to end up with, the 2x squared comes down here, 2x squared plus ix plus 1. So 2x squared plus ix plus 1. Okay? Again, all the steps have remained the same. We're not doing anything really different. We're just going through and doing what we've been doing. On this problem, now we have leading coefficients on our x terms. We have coefficients on our I terms. Doesn't really change anything. Still multiplying coefficients, adding exponents. Drawing out our multiplication array, 3x minus 2i, 7x plus 4i. 7 times 3 is 21. X times x is x squared. Okay, we add the exponents there. 1 plus 1 gives us 2. Multiplying coefficients for the second square, 7 times negative 2 is negative 14. And we bring our x and our I over. Again, we should probably write that ix. So we'll do that. The square down here below, 4 times 3 is 12, ix. For the final square, in the lower right-hand corner, 4 times negative 2 is negative 8. The exponents on I are 1 each. We add 1 plus 1 together, we get 2. So we get negative 8i squared. Like terms, 21x squared minus 2ix, that would be negative 14 plus 12, minus 8i squared. Where again, we're going to take I squared and replace it with negative 1. So we end up with 21x squared minus 2ix minus 8 times negative 1. And we end up with 21x squared minus 2ix plus 8. Again, same thing we've been doing.